Okay, so today we're going to start on the inverse trig functions. Which is kind of the same thing we've done before, but we're just changing the x's to u's. So a squared, or du over the square root of a squared minus u squared is equal to sine inverse of u over a plus c. And the integral of du over u times the square root of u squared minus a squared is equal to 1 over a secant inverse of u over a plus c. And the integral of du over a squared plus u squared is equal to 1 over a tangent inverse of u over a plus c. Okay. Now, one way you can kind of recognize these, which usually helps to remember them, sine inverse and secant inverse have square roots. So you have s, s, and s. That's one way to kind of help remember it. So move that over a little bit.
Sine inverse
and secant inverse have square roots. The tangent inverse doesn't have a square root. But the secant and tangent are the only ones that have the 1 over a in front of it. All right, anyone still writing? All right, so let's say, for example, you want to solve the integral of -3 over the square root of 36 minus 81x squared with respect to x. Okay. So here you have the square root of a number minus a variable term. So it looks like the integral of du over the square root of a squared minus u squared, which is equal to sine inverse of u over a plus c. Okay, so you have your square root and you have your number minus your variable term. Okay, so the first thing you want to do here is just factor out your numerator. Might as well factor out the negative with it, -3. Okay, so if we bring that -3 out to the front, you have -3 times the integral, and you just move the dx right up top. Dx over the square root of 36 minus 81x squared. And really, step 1 and step 2 you can do at the same time. I just separate them for explanation purposes. Okay, so the second step, you rewrite it. Okay, so you're going to notice that 36 is just 6 squared. So 36 equals 6 squared, and 81x squared is just 9x squared. So we're just going to rewrite them, replacing those. So you have negative 3 times the integral of dx over the square root of 6 squared minus 9x squared. Okay, where your a is equal to 6 and your u is equal to 9x. Okay, so you're going to take those, and I usually just draw a little box. So you have a equals 6. Your u is equal to 9x, which means your du is equal to 9 dx, which means, put that there, du over 9 is equal to dx. Okay, and that takes us to our third step, which is replace and integrate. Okay, so we have our negative 3 times the integral, our dx. We can replace that with du over 9. Or 1 over 9 times du, whichever one makes you more comfortable. So we have our square root. We have a squared minus u squared. So we can get that 1/9 and just bring it out to the front. So we have negative 3 over 9 times the integral of du over the square root of a squared minus u squared. Okay, so this just simplifies to negative 1/3. And that'll be times the integral of du over the square root of a squared minus u squared. That's our sine inverse of u over a. So that's sine inverse of u over a plus c. And then we just replace our u and our a. So that's negative 1/3 times sine inverse of u over a, so that's 9 over 9x divided by 6 plus c, which just simplifies to negative 1/3 sine inverse of 3x over 2 plus c. Like I said, for the most part, steps 1 and 2 can be done at the same time. Yes.
Out of curiosity, because we only had like 3 identities at the first, why don't we have like 3? It seems like we usually had 6.
Because with sine, the only difference between sine inverse and cosine inverse is a negative sign.
Right. Okay.
So instead of making it a whole new set to remember, we'll just make it negative sine instead of cosine.
Okay, gotcha.
And it's the same thing with secant and cosecant.
Yeah.
I mean, cotangent. What was it? Cosecant and cotangent. So it makes it a little bit easier.
Absolutely.
Out of curiosity, how did you factor out the du?
Oh, the du.
Replace and integrate, I mean. Where, like, so when you integrated the du,
Mm-hmm.
wouldn't it be 1 over the square root of a squared minus u squared?
Which?
Last step.
Oh, that's for secant. Has the 1 over a.
Right, but in this one we have du over.
Oh, okay. So let me see. Oh, you mean for this step?
Yes.
To this one?
Yes.
Oh, that goes to the integral here.
Oh, okay.
Yep, so it's just that formula. Once we get it in that form, it just
then
goes to that.
Will just, okay.
Yep, so it just kind of integrates right to there.
Yep.
All right, any other questions on this one?
Do you always
Oh yeah, if you can. If you can't, then
I think
it's good there.
the homework doesn't matter if you simplify it. I
Oh.
notice half the time I don't simplify it.
Oh, and they
I
still-
still give the right answer. They'll show you the simplified version.
Oh, but
they'll still count
they'll
the
take
other.
it.
Yeah,
Oh.
they'll take it.
Oh yeah, they take it. Yeah, I wouldn't worry about doing the extra work. All right, anyone still writing? Yep. All right, keep that up for a few seconds. All right. So let's say, for example, whoops. If we wanted to integrate 3 over 4 plus 100x squared with respect to x.
Same thing. You know.
Yep. Remember, sine and secant are the only ones with.
This one's a tangent.
Yep, that one's a tangent. The sine and secant are the only ones with square roots. Okay, so this one looks like the integral of du over a squared plus u squared equals 1 over a times tangent inverse of u over a plus c. Okay, so just like before, first thing we're going to do is factor out our numerator. So factor out the 3. So that gives us 3 times the integral, and just move the dx up top just to have it in the same form. So 4 plus 100x squared. Okay. Then your second step, you're going to rewrite it. Okay. So we know that 4 is just 2 squared. And 100x squared is just 10 squared. All right, so that gives us 3 times the integral of dx over 2 squared plus 10x squared. So that means our a is equal to 2, and our u, I'm about to say b, u is equal to 10x.
That's 10x squared, right?
Nope, just the 10x. Because remember, it's u squared, so whatever is in there is going to be squared.
Yes, exactly. Square.
Yep, so you don't need the square for the u.
I was looking to rewrite, I'm sorry. I know you were just doing that.
Hmm.
You just wrote 10 squared on the rewrite.
I did. Oh, okay, I see what you're saying. Thanks.
Yeah.
I know, I completely missed that one. Yep, so 10x squared.
Sorry, I was just that far behind.
Oh, nope, I'm glad you caught it.
As I'm writing, I'm like, that's not right.
Yep, so 10x squared. All right, so we know that a is equal to 2, and our u is equal to 10x, which means our du is going to equal 10 dx. Divide both sides by 10, du over 10 equals dx. Okay, so our third step is just replace and integrate. Okay, so that means this will become 3 times the integral of dx, which is du over 10, divided by a squared plus u squared. Okay. And if we get that 10 and bring it out, that's just 3 over 10 times the integral of du over a squared plus u squared. Yep, which is 3 over 10 times 1 over a times tangent inverse of u over a plus c. And if you wanted, you can leave the plus c on the outside because 3 over 10 times a constant is still a constant, so you don't have to add it there. Okay, so now you just replace u and a. So that gives us 3 over 10 times 1 over a, so that's 1/2. Tangent inverse of 10x over 2 plus c. Okay, so we go ahead and multiply those two. So that's 3 over 20. We'll bring that up a little bit. Times tangent inverse. 10x divided by 2 is just 5x plus c. That's your final answer. All right, so any questions on that one? All right. That one. All right, anyone still writing? All right. So let's say for our next example, we wanted to integrate -1 over 5t times the square root of 25t squared minus 25 with respect to t. All right, now this one looks like the integral of du over u times the square root of u squared minus a squared equals 1 over a times secant inverse of u over a plus c. Because you have your variable term on the outside of the square root.
Will you ever get equations where it's harder to, like let's say you have 25t squared, and we get the square root is 5. Do you ever get one where it's a number that's going to end up being a decimal?
Not in here, but when you go to Calc 2, you'll get some that might be a little bit different. But usually there, even if you have a number, if you get the square root of it and square it, it's still the same thing. So if you had 3t squared, that would just be square root of 3 squared.
Yeah, but the outside will stay, like the u on the outside will stay as a decimal.
No, but actually you can change that one too. In the next example, we're going to have it, because this one, if you make that 5t squared and 5t, that one matches up. But the next example, they don't match up.
Yeah,
and I'll show you how to do that. All right. So again, first thing you want to do is factor out your -1. Factor out, well, you don't have to factor out -1, just the negative. Oh, forgot to factor out the -1. Clean that up a little bit more. Okay, so you have -1 times the integral of 1 over 5t times the square root 25t squared. Actually, just bring the dt up top. Makes it a lot easier. Minus 25. Then your second step, you're going to rewrite it. once again, we have our 25t squared equals 5t squared. And 25 is just 5 squared. So that gives us -1 times the integral of dt over 5t times the square root of 5t squared minus 5 squared. Okay, so these two u's have to match. So you know that u is equal to 5t. And a is equal to 5. Okay, so that gives us our a equals 5, and our u is equal to 5t, which means our du is going to equal 5 dt. So you have du over 5 for our dt. Okay. Which takes us to our third step, replace and integrate. Move that up a little bit. I should have enough room. Okay, so now we just go ahead and start replacing what we need. Okay, so dt is du over 5 divided by 5t, remember that's our u, times the square root of u squared minus a squared. And that 5 can just be brought out. So we now have -1/5 times the integral of du over u times the square root of u squared minus a squared, which is just -1/5 times the integral, not the integral, times 1 over a, because that is just 1 over a secant inverse of u over a plus c. And once we replace our u and a's, we have -1/5 times 1 over a, so that's 1 over 5, secant inverse of u over a, so it's 5t over 5, plus c. And just go ahead and multiply those two. So you have -1 over 25. Oh, bring that up a little bit. Secant inverse, 5t divided by 5 is just t, plus c. All right, so any questions on that one? So as long as you recognize the formula, it's just the same 3 steps.
This is very similar to what we did last week, right?
Yep.
Just
Really,
trig function.
exactly. Yep, just substitution with the trig function.
So we're gonna go later on in the class today, we're gonna go from we're gonna actually get numbers.
Yep, actually that's the next example. Okay, and really once you had your definite integral, instead of the plus c, you would just go from one to the other, so you plug in the top one minus plugging in the bottom one. But same steps other than that. Everyone's still writing. Looks like everyone's done. Might as well restart it since it's going to